Hi everyone, this is our first video on linear functions, and I want to give us a quick introduction to what is a linear function and what we can expect out of this section in the course. So as you see here, I have three graphs that are drawn. There's a green one, a red one, and a blue one. And if we look over here on the left, we'll see that the equations are right here. So the equation of the red line is given by y equals 2x plus 5. The blue one is y minus 3 equals 1/3 x plus 1. And the green line is given by 3x plus 2y minus 10 equals 0. So when we look at these graphs, we see that all three of them are straight lines. And so that gives us a clue that we're dealing with a linear function. And all three of these forms over here, we see that this form right here for the red one is called our slope-intercept form. The blue form is called point-slope form, and the green form is called the general form of a linear function. And so for this course, the two that we're going to spend the most time on are these first two. They're going to be slope-intercept form and point-slope form. So what we have is there are two big pieces of a function, a linear function. The first one is slope, and the second one is a point. And it could be really any point, and depending on which point we have, that leads us to the names of these different forms. So if we have any point, then we can use this form that's called point-slope form. And if we have particularly our y-intercept, then we can use this form, which is called slope-intercept form. And so in future videos, we'll have a video that goes all about the slope-intercept form, and we'll have a video all about the point-slope form. All right, so there are three examples here, and what I want to do next is talk a little bit about the important property that we have, which is slope. So I suspect that a lot of us are already familiar with this form of a linear function, f of x equals mx plus b. And so this letter m is our slope, and b gives us our y-intercept. So what I have done here is I've put these things on sliders. So I've put my slope on a slider. So if I move this line around, right, so if I slide this button here, you can see that my slope changes, my line changes. And if I move B, you can see that my line seems to slide up and down, and the point where it crosses the y-axis, or the y-intercept, changes based on these things. So for the remainder of this video, I'm going to talk about slope. So if we have a negative slope, as I do right now in this graph, notice that the line, it seems to go down. So if I move from left to right, so if I'm moving along my x-axis from left to right like this, you'll notice that it seems that the slope of my line starts to go down from left to right. So this is how we can identify a negative slope. And the more negative I get, so if I come over here, I'm going to take this slider and I'm going to move it down to the left, which means my values will get more negative. So I'm still going down from left to right, but it seems like the steepness of my line is growing. So my line is getting more steep. It's getting more vertical. So it's getting closer and closer to a vertical line. So the larger my slope is, the more vertical we're going to be. And so by large, I mean sort of further away from zero. And the closer to zero I get, the flatter my line is going to be. So if I have very small slopes, very small numbers that are close to zero, my line is going to appear almost flat. And so in fact, if we do make our slope 0, we see we get a horizontal line. Now, if I move this positive, we see that as I move from left to right, my line is going up. So I'm going to move this direction, and it seems like my line is increasing from left to right, and that's a way we can identify a positive slope. And the more my slope gets, the higher it gets, the more vertical my line will be. So as I drag this up, you can see that my line gets more and more vertical. So one way to identify slope is by the steepness. It tells us how steep our graph is. But if we want to put it in context, talking about steepness is not always very helpful to me. So what I want to do is come down here and look at this table. So I've created a quick table here for us that has some inputs and some outputs. So right now, the function that I'm looking at is f of x equals 1 times x plus 3. And if I have an input of 1, I'll have an output of 4. Okay, so I have an input of 1, I have an output of 4. If I have an input of 3, I'll have an output of 6. And if I have an input of 7, I'll have an output of 10. So what I should be able to think about is the steepness of my graph should have something to do with how much my output is changing. And in fact, one of the things that we say slope measures is if I have one additional unit of input, how much more output do I get? So let's go and let's put a 4 here. And so what I've done is I've created, let's see if we can put even more entries in our table. So we'll have 1, 2, 3, 4, 7. What I'll do is if I look over here and say, if I have an input of 1 and I increase that by 1, so I'm going to go from 1 to 2, how much does my output change? And so with this table, what we're seeing is if I have one more input, then my output goes up by 1. So the fact that this is a 1, this goes up by 1, corresponds to this number here, 1. Okay, so if my slope is 1, then every time I have an additional input, I'm going to have one additional output. So let's go over here and let's change our slope. Let's make our slope 2, and I want you to observe what happens to the values in our table. So by making my slope 2, what I should see is every time my input goes up by 1, my outputs should go up by 2. So let's go ahead and check that. So if I come down here, my input went up by 1, went from 1 to 2, my outputs went up by 2. My input went up by 1, my output went up by 2. And so if we change our slope to 3, okay, so if I change this number to 3, what I'll see is every time my input goes up by 1, my outputs go up by 3. So the slope measures if I have one additional unit of input, if I have one more input that's added into my function, what's the change in my output? And so in different contexts, sometimes we call this the rate of change, right? How fast is your output changing? Sometimes people call this the marginal change. How much does everything change based on one more unit of input? And so that's what we see here. That's what our slope is measuring. If I have one more unit of input, how much more output do I get? And that's what we're measuring, this slope. All right. So in the future videos, what we're going to do is we're going to see not only what does slope mean, but we're going to take this and we're going to see it on a whole lot of different ways. We're going to ask ourselves, if I just see the graph of a function, how do I find the slope from a graph? What if I'm given a table? How do I find the slope from a table? Now in this case, we had these inputs that changed by 1, and we were able to pick out the slope, but we might not always see a change of input in 1. So we're going to see, well, given a table or given some number of points, how do I find the slope? And then we're going to explore the different forms of our linear functions. In particular, we're going to look at the first two above here. We're going to spend a lot of time talking about slope-intercept form, and we're going to spend some time talking about point-slope form. All right, see you then.